Alright guys, today we're taking a look at part 2 of 2.2. This is all about graphing parabolas and more so really our three different ways that we can have our equation written. I know in 2.1 we talked about vertex form, which is all based on those transformations, but we still have two other ways that we can write this as well. So, just in general, we know our quadratic functions is going to be, our independent variable is going to be x, r raised to the second power. So anytime we have x as our variable and we have squared as our highest exponent, we know that's the requirements for a quadratic function. We know the graph of a quadratic is called a parabola. All of this is review, parabola. And these are the three different ways that we can have the equation written for a quadratic. This middle one we already recognize, we should recognize. This is vertex form. Vertex form. Right, a times x minus h parentheses squared plus k, as we looked at for 2.1. Our other two options here, this first one all the way to the left, this is what we call standard form. Which makes sense because if you think back to Algebra 1, standard form of any polynomial is in descending exponent order. So here we have x squared, x, and then just a constant for my three terms in it. So that's going to be in standard form. The last one, all the way to the right, you can see that my two variables are factored out, which is why, shockingly enough, we call this factored form. Factored form. All right. So a quick little recap of just some general things about parabolas. These are things you already know, so we'll go through them quickly. Notice all three of those. A is the lead coefficient. That's the very first number. And that's a really important one when we talk about the general shape of my graph and which direction it opens. We know that if that A term, that lead coefficient, is positive, my graph opens up. And if it's negative, the graph opens down. A quadratic equation, all quadratic equations, we know have a vertex, which is the turning point of the graph. They also have that AOS we talked about yesterday and the day before, which goes through the vertex. Here, notice this particular quadratic equation that we've graphed crosses the y-axis once, right here at, what is that, 0, 3? 0, 3. On the x-axis, I guess I was trying to just write that once. On the x-axis, twice, two different spots, here and here. I was going to specifically label, again, this should be based on what we talked about yesterday. We got our vertex there, our AOS is there. The vertex happens at 1, 4. That means my AOS is x equals 1. My y-intercept happened there at 0, 3, like I had just said. And then our x-intercepts, one is at -1, so -1, 0. And the other one over 1, 2, 3. So 3, 0. So that's just the key points. Not every single quadratic equation that we graph, not every single parabola is going to have all of those things. At minimum, every single parabola is going to have those three things. They're going to have a vertex, they're going to have an AOS, and every single graph has to have a y-intercept for the ones that we're graphing vertically. We might have some eventually, like in 2.4, where we start looking at parabolas defined horizontally, where you could have something that avoids the y-axis. But for our standard regular old parabolas, you're going to have exactly one y-intercept. All right, so jumping into standard form. How we are going to handle graphing a parabola or a quadratic in standard form is a little bit different. Because we can't just use the fact that I know my parent graph has a vertex at 0, 0, and then just do some shifting. I also can't just plug in random numbers. I know that I've emphasized before in the past that I need at least 5 points for a parabola in order to be able to graph it properly. But we don't know in these standard equations, just by looking at them, we don't know where that vertex happens. So we have to have a way that we can figure out where that vertex happens. And we have a formula that tells us what the x value is for my vertex. So really, this formula I could have labeled the AOS formula instead, because this gives the x of the vertex. It doesn't give you the whole vertex. So in this case, my formula to start finding the vertex is x equals negative b over 2a. So negative b over 2a is how I find the x value for my vertex, and then I'll plug that back in to find the y value of my vertex. So in this case, a, b, and c, we know that's in standard form. So we know in standard form it was f of x equals ax squared plus bx plus c. So now in the graph that I'm looking at here, 4x squared minus 8x plus 1, if I'm going to do x equals negative b over 2a, that's negative 8, which is a positive 8, over 2 times 4, which is 8. So my AOS happens at positive 1. And since we're graphing this, when I figure that out, I usually will just throw it on there just to have it on there. So I know that my AOS for this graph happens at positive 1. So I just go ahead and put my dotted line right there at positive 1. I know that's the middle of my graph. Now once you know that, I still need to find where on that AOS my vertex happens. And we know if that's the x value, to find the y value, I just plug that number in to my function. So here if I take this 1 and I'm going to plug it in for x in my equation, f of 1 is 4 times 1 squared minus 8 times 1 plus 1. So 1 squared is 1 times 4 is 4 minus 8 plus 1. 4 minus 8 is negative 4 plus 1 is negative 3. So that is where my vertex happens on the AOS. Actually, let's keep it in red. So 1 comma negative 3 is my vertex. 1 comma negative 3. So from here, you've got a couple of different ways that you can handle this. And it's really personal preference and how comfortable you are with your stretching and shrinking versus just evaluating points. Because, again, I just need you to have at least 5 coordinate points on my parabola in order for it to be completely graphed. So I have my middle point already, so I need 2 points to the left and 2 points to the right. So what I'm going to do, since I know here, I know when I plugged 1 in, I got negative 3. I could go 0, negative 1, 2, 3. If I make 1 be my middle point, I could find 2 to the left and 2 to the right on my parabola. Now when I do that, if that's going to be the method I choose, I'm definitely going to choose the side that's easier. Because remember, in a parabola, that dotted line is an AOS. So I don't have to find 4 more points. I only need to find 2 more points on the left, and then I can reflect it over on the right side. Or vice versa. I could find 2 points to the right, and then just reflect it over my AOS to get the other points that I need. So it's personal preference if you like dealing with positives versus negatives. Personally, I think looking at this, 0 and negative 1 would be easier to plug stuff in. Because if I plug 0 in to my function, f of 0 becomes 4 times 0 squared minus 8 times 0 plus 1, which is just 0 minus 0 plus 1. So positive 1 is my output when your x is 0. Which also tells me that 2's output is also 1. Because if you look at my graph, 0, 1 means 2, 1 as well. Right? If I just reflect that over my AOS, then I'm good. Okay. For my last one, you could either do negative 1 or you could do 3. It's kind of up to you in terms of personal preference with which one is easier for you to evaluate. So if I'm just going to use negative 1, my equation would be negative 1 equals, f of negative 1 equals 4 times negative 1 squared minus 8 times negative 1 plus 1. Negative 1 squared is 1 times 4 is 4. Negative 8 times negative 1 is a positive 8 plus 1. So I end up with 13. 13. Which I think is off my graph, isn't it? Yeah, way off my graph. So that's okay, as long as I can see that you made an attempt at getting it graphed correctly. That's fine with me, and just make sure your graph kind of reflects that being off the graph by that much. So now that I have my points, I know, oh, that's an ugly parabola, but that's all right. We're going to make do with what we got. Just see that it's a nice steep parabola. The other option you do have, if you didn't like that method or it seems too cumbersome for you, if you want to continue to use that A value, just like we did with our stretching and shrinking, you could still apply the 135 shortcut with that 4 as your multiplier. So like here, once you figured out that 1 comma negative 3 was your AOS, usually we would go up 1 over 1, up 3 over 1, up 5 over 1. But since I have an A value of 4, I would go up 4 over 1, up 12 over 1, and then up 15 over 1. Or sorry, up 20 over 1. So that's another option for you. It's really up to you which one makes more sense in your brain. But as long as you find that vertex and then you find 2 points to the left or the right, the method that you choose to utilize that or to do that, to identify those points, is really up to you. It's personal preference. All right. Next one, vertex form. This should be easy. This should be a review for us because this is what we did in 2.1. I just wanted to remind you of what it looks like. So in this one, if we're just identifying the vertices of these equations, a parenthesis x minus h, close the parenthesis squared, plus k, we know that h comma k is my vertex. So that's shifting it to the right and up k. So in this one, if we're this first example, if we're just trying to identify the vertex of that equation, it would be 2 comma 4 because it got shifted to the right 2 and up 4. The other one here, negative 4 parenthesis x plus 3 squared minus 5, that vertex would be negative 3 comma negative 5. Because again, inside that parenthesis is always opposite of what I see, so that's shifting it to the left 3. Right, we would have to subtract a negative 3 in order for it to look like plus 3. So that's why it's a negative 3 and a negative 5. Okay, so as soon as we start to try and identify these, this one should go much quicker because we can really, really quickly identify what that vertex is. 3 comma negative 4 is my vertex. Right, 3 down 4. So that's my is my AOS, right? Because again, that's 3 and negative 4. Now our A value is 2, which means it opens up, and instead of my 135 shortcut, I could just multiply all those things by 2 to get my points without having to use the table. So instead of going up 1 over 1, I can go up 2 over 1 on either side. Next, I would usually go up 3 over 1, so 3 times 2 would be 6. So I'm going to go up 1, 2, 3, 4, 5, 6 over 1, and the same thing over here. That gives me 5 points. I draw a nice, smooth as possible curve that goes through all of those points. And look at that, we're done. That one's super easy. That's why we like vertex form. It's nice and easy to graph. All right, last form. Very last one, factored form. This one a little bit different, and really, we're only really presented with this certain times and in certain scenarios. If this is something that you really enjoy doing and you're good at factoring, you remember how to factor, that's going to be necessary for you if this is not given to you in this way. But again, it's up to you on your personal preference. Usually it's more so for me important that if I give you a certain form, you're able to handle that without necessarily having to convert between the different ones. But as always, it's up to you on your personal preference. So in this case, we the equation that we're given, we can use this to find what my intercepts are, my x-intercepts, which hopefully remember we call those, whoops, that's not my highlighter yet. We call those my zeros. And we called the x-intercepts zeros because if we let f of x be 0, or my y value be 0, and we solved that equation, the two values that I'm given ended up being that x-intercept, or those x-intercepts. So in this case, if we were going to do that, if we let f of x be 0, we have x minus 6 times x minus 2. And if you remember back from Algebra 1, zero product property, ZPP, told us that if we have a product of two things that equals 0, either this left one could equal 0, x minus 6 could equal 0, or x minus 2 could equal 0. So I get pretty quickly and easily that positive 6 and positive 2 are my two solutions. Now in this case in particular, those two values are my x-intercepts for my graph. So positive 2 and positive 6 are my two x-intercepts. Now, that's great, but we still need to know what the vertex is. We don't know where that is. We don't know where my AOS is, but we could figure that out. We know that if my graph is symmetrical, my AOS has to be halfway between any 2 points that have the same x value. All right, if these 2 points are both when x is 0, or sorry, when y is 0, my AOS has to be exactly halfway between those two. So you can do this a couple of different ways. You can see here I've got the formal way of how we calculate that. It's just averaging those two x values. But also you can just look at it visually. There's 4 spaces between 2 and 4, or sorry, between 2 and 6. So halfway between those two is where that AOS has to happen. Now, from here, this is basically like going back to our standard form problems. You know what the x value is for your vertex. In this case, x equals 4 is my AOS. So I can take that x value and plug that back into my equation to figure out what the y value is. So I'm going to change to red for that. So if I plugged in 4 for my equation, f of 4 equals 4 minus 6 times 4 minus 2. That gives me negative 2 times positive 2. So negative 4 is the y value for my vertex. So I'm going to go back over here. Negative 4 is the y value for my vertex. Now, to finish off the problem, I do still need 5 points total. I have 3 so far, so you've got a couple of choices on what x values you could plug in to find more y values. You could plug in what I would suggest, either 3 or 5. If you plug either of those in, you should get points between, somewhere along this approximate path. It's going to look something like that. So my guess is that we'll end up right here and right here. But just to make sure, you can plug it in. If you plug in 3 or 5 into your equation, let's just do that over here in green. So f of 3 equals 3 minus 6 times 3 minus 2. That gives me negative 3 times 1, which is negative 3. So I go back over here, and hey, look, it was negative 3. Yay! Woot, woot. Which actually, if you look at it, does make sense. In order for that 135 shortcut to hold true, I need to go up 1 over 1, up 3 over 1. So I guess that's another way that you could, come back. That you could try and handle this problem. Stop leaving. Sorry, peoples. Gotta just go ahead and regraph that. I wanted to unhighlight that stuff, but it seems more trouble than it's worth. All right, last one. For this one, our equation is a little more complicated. You'll see why it's more complicated. So here, again, I'm going to just jump right to solving it for my two x-intercepts. In this case, I get negative 1 and positive 4 are my two x-intercepts. I just set each of those equals 0. So -1, stop popping up. -1, +4 are my two x-intercepts. So halfway between those two, well, there's 1, 2, 3, 4, 5 spaces between those two. So halfway between the two of them would be right here. 2.5 spaces from either side. So if that's the case and you don't feel confident in identifying this definitively as 1.5, you also could use the formula then. Right? My formula for my x value of my vertex is x1 plus x2 all over 2. So -1 plus 4 over 2 is 3 over 2, which is 1.5. So 1.5 is the correct AOS here. Now, going back to my formula, again, I have to plug that in to find the y value for my vertex. F of 1.5 is equal to 1.5 plus 1 times 1.5 minus 4. So that is 2.5 times -2.5. Fun stuff. So that comes out to, I think, -6.25. Grab my calculator and make sure real quick. But from here, once you have that point, again, we have to still find 2 more points. 2.5 times 2.5. Yep, 6.25. And it's negative because that 1 minus 4.5 is -2.5. So we end up with -6.25 and -1.5 comma -6.25 would be my point. Now from here, we've got a couple of different options depending on what you're most comfortable with. You could try and do your shortcut, the 135 shortcut. In this case, I didn't have anything out in front of my parentheses, so my a value would be 1. So you could just go up 1 over 1 from the vertex. But you can see it's kind of floating in the middle of nowhere. So if we went up 1 over 1, it would be somewhere like here and here, which is not the nicest. But still would work. It gives you 2 more points, so that gives you your 5 points total. The other option that you have, and what I would suggest doing, since you know your vertex, you've got your 2 x-intercepts, just pick some other whole number x value between those two things in order to find another point. And especially when you have the option to choose 0 for one of your x values, do that. It makes it so much easier. Working with zeros are so easy. So what I'm going to do, I'm going to take and just do that. I'm going to go ahead and green here. If I find f of 0, 0 plus 1 times 0 minus 4 means 1 times -4 gives me -4. Pretty darn easy. So I know when my x value is 0, my y value is -4. Now if I reflect that over my AOS, I go 1.5 units to get to my AOS. So I go 1.5 unit to get past it. So 3, -4 is another point. So you get nice at least 4 nice clean points. And then my vertex, unfortunately in this case, is just not nice no matter which way you slice it. So that's all we got. So take a look at Google Classroom. I have the homework for today posted on here. So you guys can start working on some practice problems out of the textbook for this section right now. We also will be, we know tomorrow is its own day with just getting caught up on stuff. But on Monday next week will be another practice day on this, just because there is so much information to process with this. I want to make sure I give you guys enough time to be able to refamiliarize yourselves with the methods you already know on how to do parabolas from the quadratic equation. And especially with this factored form and our standard form, making sure we have time to practice those things. So, as always, if you have questions, if you are confused on anything, and you've tried rewatching this video over and over again or re-listening to me explaining it, and it still doesn't make sense, just reach out and ask for some help. You know that I'm here. You know that I'm willing to meet with you and work with you. You just got to let me know that you need that. All right. Well, have a fantastic day, and I will see you guys tomorrow.